Hi, welcome to Cool Guy Podcast YouTube channel.
What is actually this three-eye atlas?
Today we're digging into, well, one of the most baffling objects we've seen flying through our solar system. Three-eye atlas. This thing, it's an interstellar visitor, and it's really making scientists scratch their heads. It's just not acting like a normal comet.
Yeah, absolutely. And the name itself tells you a bit. 3I means it's only the third interstellar object we've confirmed. It was picked up by the AT-LAS survey, that's a NASA-funded telescope, back in July 2025. We call it a comet because, well, it's active. It's got that fuzzy cloud, the coma.
And it's moving incredibly fast, isn't it? Something like 137,000 miles an hour?
Around that, yeah. 61 kilometers per second when found. And crucially, its path is hyperbolic. That just means it's moving too fast to get caught by the sun's gravity. It came from interstellar space, and it's heading right back out.
Okay, so it's just passing through, but it's pretty big, right? Hubble clocked it at, what, 3.5 miles across?
Roughly, yes.
Yeah.
A substantial object, but the trajectory, the path it's taking, that's where things start getting really strange.
How so?
Well, think about it. If something comes flying in from deep space, randomly, it could come from any direction, right? Above, below, sideways relative to our solar system. But 3I Atlas, its orbit is almost perfectly flat. It's tilted only about 3 degrees compared to the ecliptic plane, that flat disk where Earth and the other planets orbit.
Only 3 degrees. That sounds unlikely.
It's extremely unlikely. Statistically, that just shouldn't happen for a random visitor. And add to that, its chemistry suggests it might be really old, maybe 7.6 billion years. Possibly from the galaxy's thick disk, which is a much older part of the Milky Way.
Wait, so it's ancient? Possibly from a totally different part of the galaxy, but it arrives lined up almost perfectly with our little planetary plane? That feels, well, not random at all.
Exactly. That alignment is the first major puzzle. It kind of hints at something more organized, or at least a formation history we don't understand.
Okay, so its path is weird.
Yeah.
What about the object itself? What's it made of?
That's anomaly number 2. See, most comets we know are basically dirty snowballs, mostly water ice. They only start getting really active, forming that coma, when they get closer to the sun, where it's warm enough for water ice to turn straight to gas. But 3I Atlas started forming its coma way out past Jupiter at 5 AU. That's astronomical units, 5 times Earth's distance from the sun. It's cold out there.
So not water ice then?
Doesn't seem like it was the main driver initially. The thinking is it must have been dominated by something like carbon dioxide ice, dry ice. That turns to gas at much lower temperatures, so it was kind of running on a different fuel system. And that early gas cloud, it also showed the most extreme negative polarization of light ever recorded.
Negative polarization, what does that tell us?
It hints that the dust grains on its surface, or maybe in that early coma, are really, really unusual in shape or texture. Very irregular.
Okay, so weird path, weird early activity, strange surface dust.
Yeah.
What else? I heard something about acceleration.
Ah, yes. This is probably the biggest mystery. After it swung past the sun, around October 30th, 2025, astronomers tracked its path very carefully, and they found it wasn't quite following the path gravity alone would dictate. There was this tiny extra push, a non-gravitational acceleration.
Like a thruster.
Sort of, but continuous and very faint. Now, for a normal comet, we see this sometimes. As ice turns to gas and shoots off, it acts like a weak rocket engine. It's called outgassing. But to get the amount of acceleration they measured for 3I Atlas, it should have been blasting out a huge amount of dust and gas, like maybe 13% of its entire mass.
And we should have seen a massive cloud.
We absolutely should have. But there wasn't one, or at least nothing nearly big enough to explain that push. It was accelerating almost invisibly. The implication is that whatever material was being ejected, it must have been coming off at incredibly high speeds, maybe 100 times faster than typical sublimation. That's not easy to explain naturally.
Wow. An invisible engine made of, what, CO2 ice? And there were other oddities too, weren't there? Like low water.
Yep, very low water compared to solar system comets, maybe only 4% of what we'd expect. And early on, before it developed a normal tail pointing away from the sun, it had this weird jet pointing towards the sun, an anti-tail.
Strange. And didn't it fly pretty close to Mars? Any data from that?
It did on October 3rd. The Mars Reconnaissance Orbiter was watching, but apparently there might be a delay in getting that data out because of some government funding issues, so we wait on that.
Okay, so let's pull this all together. We have an object from interstellar space lined up improbably with our solar system, activating early with weird chemistry, and accelerating without any visible means of propulsion. What on earth does this mean?
Well, it forces us into uncomfortable territory. You have this combination, The alignment, the steady acceleration, the exotic chemistry, like a high nickel ratio too, which is unusual, and the low water. It means either there's some kind of new, super efficient natural physics happening that we've just never seen before, or this is something else entirely. A different class of interstellar object, maybe something engineered, or maybe just a type of natural object, common elsewhere but completely new to us. We simply don't have a good model for it right now.
And that acceleration being steady, not just random bursts like a normal comet might do, that does make it feel more controlled, organized. So does this push the boundaries of what nature can build? Or is this maybe just the first glimpse of how things are put together in other star systems? Maybe structures that are just naturally better at moving themselves around. That's definitely something for you to think about and for all of us to watch as scientists keep trying to decode this amazing visitor.